Okay, so this is a big tricky graph to draw. We'll do a few examples so you can see how they work out. Okay, so the graph can only go through 0 when x is equal to -3. There's no other number you can put in for x that'll give you 0. And you get a 0 in the denominator, but you know that's what makes it blow up here, right? So the other thing you know is near x equals 2, the thing either has to be way up or way down. Because if x is close to 2, you got a tiny denominator and a numerator close to 5. Okay, tiny number goes into 5 a lot of times. If the tiny number is negative, it goes in and gives you a large negative number. Okay, if it's positive, it gives you a large positive number. So we've got to go through these points. Let's just start with that. We've got to go through these points. We can't go through the x-axis anywhere except here. It's got to be positive on the yellow interval, negative on the purple interval, positive on the orange interval. Okay? Well, and we've also got to get close to this y equals 1 line when x is far to the left or far to the right. Well, we can do that at least up to the negative, at the x equals 2 line. We can do that sort of like this. Okay? So the graph just could do something like this. Now, I'm kind of exaggerating. It's only going to be about this high here instead of this high, but I want to make it look like it's close to this line, so I'm fudging a little bit. Don't leave myself enough room. Okay? But kind of a very simple thing. It's got to dive down here because it's negative. Okay? Everywhere on this side of x equals 2, the function is negative. And it's going to be really big, either big up or big down as you approach this line. It's going to have a vertical asymptote at this line. So it's got to be negative since it's negative. It's not going to go down here and then try to come back up because then it wouldn't be getting big, right? Okay, so we have that. And then on this side, well, it's got to be really big near this line. It's got to be positive. So that means it's got to come down from here. Okay? And then it's got to approach this line because for big positive x, it's got to approach this line here. Now that's kind of a little bit tricky because there are a lot of things to think about. You got to think about all these things. So to solve one of these problems, you have a rational function. What's the first thing we did? Well, we noticed where the numerator was 0, where the denominator was 0. Numerator 0 gives us a 0. Denominator 0 makes it undefined, so we're going to end up with a vertical asymptote. Because as you get close to the denominator being 0, your denominator gets tiny, your quotient gets huge. Okay? And also we always figure out the y-intercept because that's always so easy. We just plug in 0 for x, right? So we mark these points. Then we figure out whether the function is positive or negative on each interval. Now I did it by just reasoning out what the sign of each quantity is. You can also do it, and this is what is usually taught, is you just pick any number in the interval and plug it in and see whether you get a positive or negative. You can't change sign on any of these intervals. You can only change sign if x plus 3 changes sign or if x minus 2 changes sign. X plus 3 only changes sign by going through 0. X minus 2 only changes its sign by going through 0. Okay? So only at the zeros can you change the sign. So there's reason behind all these rules, and it's not a difficult, the reasons are not difficult to understand, especially in terms of a simple function like this, but if you can do this one, you can pretty much do any of them. Okay? So what's our procedure? You find the zeros in the numerator and denominator. Okay? Partition the x-axis. We partition the x-axis at these points. The partition just consists of this interval, -3, 2 in this case, to infinity, and I didn't have room to write it, but that would be -infinity, -3, right? You get 3 intervals. If you've got more zeros, you've got more expressions up here in the numerator, you get more zeros, and you'll have more intervals to worry about. Okay, so that's the first two things we do. Didn't leave myself room to write it. And then the end behaviors. And then you graph it, making sure that the graph does everything these behaviors tell you it does. Okay? So let's try another one.